Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 13 of your science book, that is magnetic effects of electric current. And in today's video, that is part 7, electric generator, we will be studying about electric generator. Students, as the name indicates, electric generator is something which is going to generate electricity. So, here we will learn that how mechanical energy is being converted into electric energy, and the device hence is named electric generator. So, students, electric generator. The electric generator is a machine used for producing electric current or electricity. The electric generator converts mechanical energy into electrical एनर्जी. सो स्टूडेंट्स यहाँ पर क्या है, इलेक्ट्रिक जनरेटर जो है वो एक डिवाइस है जो कि मैकेनिकल एनर्जी को इलेक्ट्रिक एनर्जी में कन्वर्ट करता है. Moreover students, the principle of electric generator. The electric generator works on the principle that when a straight conductor is moved in a magnetic field, then current is induced in the conductor. That is, electric generator is based on the principle of electromagnetic induction. So, बच्चों यहाँ पर जो इलेक्ट्रिक जनरेटर है जो कि मैकेनिकल एनर्जी को इलेक्ट्रिक एनर्जी में कन्वर्ट कर रहा है, वो इलेक्ट्रोमैग्नेटिक इंडक्शन के प्रिंसिपल पर वर्क करेगा. नाउ स्टूडेंट्स, इन एन इलेक्ट्रिक जनरेटर a rectangular coil is made to rotate rapidly in the magnetic field between the poles of a horseshoe type magnet. When the coil rotates, it cuts the magnetic field lines, due to which a current is produced in the coil, which is electromagnetic induction. Now students, we have two types of electric generator. So, types of electric generator, the first type is AC generator and the second type is DC generator. Students, in AC generator, we will see that how mechanical energy is converted into alternating current, that is, the electricity generated is of alternating nature. And in DC generator, we will learn that how mechanical energy is converted into direct current. Right students? So, first we will start with AC generator. Now students, alternating current AC generator. Now, what is an AC generator? An AC generator converts mechanical energy into electric energy in the form of alternating current, which is abbreviated as AC. And here students, the principle is again that of electromagnetic induction. So, principle is, whenever in a closed circuit the magnetic field lines change, an induced current is produced. Right students? So, now let us see that what are the parts of an electric generator and AC electric generator. So, students, construction of AC generator. The first part is the armature. Now students, what is armature? It consists of laminated soft iron core from the center of which passes a steel axle. The axle is mounted on the ball bearings and connected to some primary energy source. Over the core is wound a rectangular insulated copper coil of large number of turns. Now here in this diagram students, you can see that ABCD, here this ABCD is a rectangular coil and this coil is known as the armature. Now students, here for simplicity we have shown only one turn, while the armature consists of many turns. Now students, here ABCD, which is shown here, like you can see this A, B, C and A, D. So, this ABCD is this armature coil, and as I told you that for simplicity we have taken only a single turn, as such it has many turns. Now students, the next part is slip rings. The ends of armature or rectangular copper coil are connected to two slip rings R1 and R2 made of gunmetal. The rings rotate along with the coil about the same axis. The rings are insulated from each other. Here in the diagram you can see, students, that we have two rings. Here you can see these two rings. First is R1 and the other is R2. So, the rings are here R1 and R2. Now, these two rings are having the same axis which was that of the armature coil ABCD. So, now here you can see this is the axle, and on this axle we have mounted these two slip rings, and these slip rings are insulated from each other. Now, you can see, students, here that the slip ring, this slip ring is connected to this slip ring is connected to the armature side AB, and this slip ring is connected to the armature side CD. So, you can see that these slip rings are connected to the armature, and each arm of the armature is connected to one slip ring, and here AB is connected to this slip ring which is R1, and CD is connected to the second slip ring which is R2. Now, let us see the next part. So, students, in the next part we will study about the brushes. They are made out of carbon or gunmetal. Their one end presses tightly against the slip rings. The current induced in the coil flows out of the slip rings through brushes. Now, here in the diagram also, students, you can see that here we have two brushes. This is brush 1, and here you can see this is brush 2, which is named as B1 and B2. So, B1 and B2 are the brushes, and what we see is that this brush is tightly pressed across this ring R1. You can see this B1 is pressed across R1 ring, and B2 is pressed across R2 ring, and here you can see that B1 is attached to the external circuit, and here B2 is now again attached to the external circuit, in which we have a galvanometer. So, here, students, you see that the brushes are not going to move. The brushes are fixed with the external circuit. So, we have two brushes, B1 and B2, and later on we will see that the current induced in the armature coil will flow through the slip rings, and through the brushes they will enter the external circuit. Now, students, we have field magnet. It is a powerful horseshoe permanent magnet with concave cylindrical poles. It produces a radial magnetic field which is highly concentrated in the middle. Now, here, students, in the diagram also you can see that we have shown only the poles of the horseshoe magnet. Here we have the north pole, and here you are seeing the south pole. Now, the inner end of this north and south pole is taken as a bit concave. Here we are not going to show it the concave poles, because here in the diagram, for the simplicity, we have simply shown the north pole and the south pole. Now, students, the inner side of the north pole and the south pole is taken a bit curved in the shape of a concave shape. We do so because we need a radial magnetic field, and to produce the radial magnetic field, what we do is we make the shape of the north and the south pole a bit concave from the inner side, right, students? Now, what we have is we will study about the working, that how this AC generator is going to convert mechanical energy into alternating electric current. So, let us understand the working. We have understood the various parts of this AC generator. Now, we will understand that how this AC generator works. Now, students, as the armature is rotated about an axis shown dotted, the magnetic flux linked with the armature changes. Therefore, an induced current is produced in the armature. Now, students, here you can see that we have made the diagram more simpler, and here we have the armature coil A, B, C and D, and this AB side is connected to the ring R1, the CD side is connected to the ring R2, and the brushes B1 and B2 are pressed across the slip rings, are connecting to the external circuit. So, what we see is that the brushes B1 and B2 are pressed along the slip rings and hence connect the slip rings with the external circuit, and here we have a galvanometer also. Now students, what we have seen here is that as the armature is rotated about an axis, this axis is shown dotted. You can see this dotted line, this is the axis, and when the armature is rotated about this axis between the strong north and south pole, here you can see that from the north pole to the south pole the magnetic field direction is shown by the green line. So, when this armature is going to rotate between the north and the south poles, the magnetic field lines are going to change, that is the magnetic field associated with each arm is going to change, hence an induced current is going to be produced, and we will see that how and what type of induced current will be produced, that is what will be the direction of this induced current. Now students, first we will learn for the first half rotation and then we will learn for the next half rotation, that is we will study the working in two parts. So, A, for the first half rotation, let us suppose that the armature ABCD is rotating anti-clockwise so that the arm AB moves inwards and CD moves outwards. Now here you can see it in the diagram also. यहाँ पर बच्चों हम क्या देख रहे हैं कि ये जो ABCD जो कि आर्मेचर कॉइल है, जो कि नॉर्थ और साउथ पोल के सेंटर में रखी हुई है, इसको हम ABCD को मूव कर रहे हैं और हम ये अज्यूम कर लेते हैं कि ये एंटी क्लॉकवाइज डायरेक्शन में मूव कर रही है। तो ये इस तरीके से एंटी क्लॉकवाइज डायरेक्शन के अंदर मूव कर रही है। तो ये जो एंटी क्लॉकवाइज डायरेक्शन है, इसके अंदर हम क्या देखते हैं कि AB आर्म तो अंदर की तरफ मूव कर रही है और CD आर्म जो है वो बाहर की ओर मूव कर रही है। तो हमने मान लिया, ये रोटेशन की डायरेक्शन दिख रही है स्टूडेंट्स आपको। अगर हम इसको देखेंगे तो ये जो एंटी क्लॉकवाइज रोटेशन है आर्मेचर कॉइल का, उसमें AB आर्म तो इनवर्ड्स मूव कर रही है और CD आर्म जो है वो आउटवर्ड मूव्स कर रही है। अब स्टूडेंट्स, अगर हम फ्लेमिंग्स राइट हैंड रूल को यूज करें इंड्यूस्ड करंट की डायरेक्शन निकालने के लिए, सो व्हाट वी विल डू इज स्टूडेंट्स, वी विल यूज द फ्लेमिंग्स राइट हैंड रूल, एंड इफ वी आर गोइंग टू स्ट्रेच द टू fingers and the thumb mutually perpendicular to each other, then recall students that if the forefinger is going to show the direction of magnetic field and the thumb is going to show the direction of motion or the direction of force, then the middle finger will point towards the direction of induced current. So students, we will use this Fleming's right hand rule and we will apply this Fleming's right hand rule and we will conclude that what will be the direction of induced current. So first let us do it for AB arm. Now since the AB arm is moving inwards, so the direction of force, that is the thumb, has to point inwards, then this forefinger has to point towards the magnetic field. Now students, what we will do is that we will just put the finger, the thumb towards inwards, that is the direction of force is inwards because AB arm is moving inwards. So this finger which is pointing towards the magnetic field, as you see students, the magnetic field is here in this direction and AB arm is moving inwards. So what I have done is the thumb is pointing inwards and the forefinger is pointing towards the magnetic field. Then what we see that the middle finger, which is going to give us the direction of induced current, is pointing downwards. So in AB arm, what we will have is that the direction of induced current will be downwards. So here what we see is that the direction of induced current in AB arm is downwards. Similarly, we will calculate the direction of current, induced current in CD arm. Now this CD arm is moving outwards and the direction of magnetic field is again the same. Now here what we will do is that the thumb will point towards the direction of motion and the forefinger will point towards the magnetic field. So, this middle finger will point towards the induced current. So, for arm CD students, what we see is that this is the direction of magnetic field, this is the direction of motion, then this is the direction of induced current. So, in CD arm, what we see is that the direction of induced current will be upwards. So, here students, the direction of induced current is going to be upwards. So, like this, what we see is that in CD arm the direction of current is like this, and in AB arm the direction of current is like this. Now, students, see that in this AB arm the direction of current is like this, and this AB arm is connected with slip ring R1. Now, this B1 brush which is pressed across the ring R1. So, what we will see is that the current will flow through the slip ring R1 and hence through B1 and will enter the external circuit. And here you have seen, students, that the direction of current is shown. So, the current will flow like this, and what we see is that through the B2 brush, the B2 brush which is pressed across the slip ring R2, the current will enter the R2 ring, and since the R2 ring is connected with the CD arm, here you can see that R2 is connected with the CD arm. So, in the arm CD the current is in upward direction, and in the arm AB the current is in डाउनवर्ड डायरेक्शन. सो स्टूडेंट्स, फर्स्ट हाफ रोटेशन में हमने क्या देखा कि जो AB आर्म है, हमने क्या माना स्टूडेंट्स कि आर्मेचर कॉइल जो है वो एंटी क्लॉकवाइज डायरेक्शन में रोटेट कर रही है, यानी कि AB आर्म जो है वो तो इनवर्ड्स मूव कर रहा है और CD आर्म जो है वो आउटवर्ड मूव कर रहा है. तो हमने फ्लेमिंग राइट हैंड रूल से इंड्यूस्ड करंट की डायरेक्शन निकाली कि AB आर्म के अंदर तो डायरेक्शन जो है वो करंट की वो डाउनवर्ड्स है और CD आर्म के अंदर जो करंट की डायरेक्शन है वो अपवर्ड्स है. और AB आर्म जो है वो R1 स्लिप रिंग के साथ में कनेक्टेड था, इसलिए B1 ब्रश से उसके अंदर से करंट एक्सटर्नल सर्किट में जाएगी और गैल्वेनोमीटर डिफ्लेक्शन दिखाएगा राइट हैंड साइड के अंदर, और फिर ये करंट जो है वो B2 ब्रश जो कि R2 रिंग के साथ कनेक्टेड था और R2 रिंग जो कि CD आर्म के साथ कनेक्टेड थी, तो R2 रिंग में से करंट जो है वो CD आर्म में चली जाएगी. तो यहां पर हमने क्या देखा स्टूडेंट्स कि एक्सटर्नल सर्किट के अंदर जो यहां पे लोड रेजिस्टेंस रखा हुआ है उसमें करंट की डायरेक्शन क्या हो गई, करंट की डायरेक्शन डाउनवर्ड हो गई, और गैल्वेनोमीटर के अंदर जो डिफ्लेक्शन है वो राइट हैंड साइड के अंदर हो गया. सो स्टूडेंट्स, हियर वी हैव सीन द वर्किंग फॉर द फर्स्ट हाफ रोटेशन. So, applying Fleming's right hand rule, we find that the induced current in the armature and in the circuit is anti-clockwise as shown in figure, due to which G shows deflection towards the right. So, this we have seen students that G shows deflection towards the right and the direction of current in the external load is downwards, since in the armature the induced current is in anti-clockwise direction. Now students, we will learn the working further for the next half rotation. अभी क्या हुआ है स्टूडेंट्स कि हमारी कॉइल जो है वो इस तरीके से थी, अब वो कॉइल कैसी हो गई है, हाफ रोटेशन के बाद में फ्लिप हो गई है. पहले इस तरीके से थी स्टूडेंट्स और अब क्या हुआ है 180 डिग्री से रोटेट हो गई है. तो 180 डिग्री से रोटेट होकर और वो जो आर्मेचर कॉइल है वो अब इस तरीके से हो गई है, यानी कि जो आर्म इस तरफ थी वो अब क्या हो गई है, वो आर्म अब इस तरफ आ गई है. राइट स्टूडेंट्स, तो 180 डिग्री से रोटेट होने के बाद में आर्मेचर कॉइल की वर्किंग किस तरीके से होगी वो सीखते हैं. सो स्टूडेंट्स, फॉर द नेक्स्ट हाफ रोटेशन, now here what we see is that now the AB arm is on this side and the CD arm is now on this side. Again applying the Fleming's right hand rule, what we see is that since the armature is rotating in the anti-clockwise direction again, because the armature coil is kept on rotating in the anti-clockwise direction. So now what is happening, that the CD arm is moving now inwards and AB arm is moving outwards. Now since CD arm is moving inwards, so by the Fleming's right hand rule, the direction of current can be again seen that the induced current is going to flow in this direction, and in AB arm which is now moving outwards, the direction of current is going to be upwards. So here what we see is that again the direction of current, the direction of induced current is in the anti-clockwise direction. Now this CD arm, since it is joined with the R2 ring, CD आर्म जो है स्टूडेंट्स वो किसके साथ में कनेक्टेड था, वो R2 रिंग के साथ में कनेक्टेड था। तो ये जो करंट है स्टूडेंट्स ये क्या होगा, B2 ब्रश से बाहर आ जाएगा, क्योंकि B2 ब्रश जो है वो किस पे प्रेस हो रखा है, वो R2 रिंग के ऊपर प्रेस हो रखा है। तो यहां से करंट बाहर आएगी, तो गैल्वेनोमीटर में जो डिफ्लेक्शन है वो अब लेफ्ट हैंड साइड में हो जाएगा, और जो एक्सटर्नल लोड था उसमें करंट जो है वो अपवर्ड डायरेक्शन के अंदर हो जाएगा। अब जो B1 ब्रश है जो कि R1 रिंग के साथ में कनेक्टेड है, या यूं कह लीजिए कि B1 ब्रश जो है वो प्रेस किया हुआ है R1 रिंग के साथ में, और R1 रिंग जो है वो AB आर्म के साथ में कनेक्टेड थी, तो यहां से करंट जो है वो इस तरीके से फ्लो होगा। सो स्टूडेंट्स हम यहाँ पे क्या देखते हैं कि करंट की डायरेक्शन एक्सटर्नल सर्किट के अंदर रिवर्स हो गई है। जैसे ही हाफ रोटेशन हुआ करंट की डायरेक्शन जो है वो रिवर्स हो गई है। सो स्टूडेंट्स, after the armature has turned through 180 degree, it occupies the position shown in figure. Here you can see the students the position now, and the armature has rotated through 180 degrees. So what we see is that here the AB arm is now on the right hand side and the CD arm is now on the left hand side. So again calculating the direction of induced current, what we see is that in the armature the current is again in the anti-clockwise direction. So students, with the armature rotating in the same direction, that is anti-clockwise, CD moves inwards and AB moves outwards. Thus again applying Fleming's right hand rule, we find the induced current in the external circuit R and G, and what we see is that the induced current in the external circuit flows in the opposite direction, due to which the direction of deflection in the galvanometer is towards left. So students, thus we see that the direction of induced current changes in external circuit after every half revolution of the armature. That is, after the armature has turned through an angle of 180 degree from its initial position, hence the induced current is alternating in nature. Hence mechanical energy is converted into electrical energy of alternating nature, that is after every half revolution, that is after every 180 degree revolution the direction of current changes. Now students, the magnitude of induced EMF in a generator can be increased by increasing the number of turns of its armature, increasing area of the armature, increasing speed of rotation of the armature, and increasing the strength of the magnetic field. So these are the ways, students, in which the magnitude of induced EMF in a generator can be increased. Now students, we will learn about the direct current DC generator, and here as the name indicates, students, mechanical energy is going to be converted into electrical energy which is of direct nature, that is the electricity hence produced is direct current. So students, the principle, construction and working of a DC generator is the same as that of an AC generator, except that in place of slip rings as sliding contacts, we have a split ring or a commutator. नाउ स्टूडेंट्स, यहाँ पर हमको क्या समझना है कि जो डीसी जनरेटर है वो एसी जनरेटर की तरह काम करता है। एसी जनरेटर का प्रिंसिपल, डीसी जनरेटर का प्रिंसिपल जो है वो सेम है, सिर्फ एक फर्क है, और वो फर्क क्या है कि यहाँ पर कंस्ट्रक्शन में जो फर्क है, बेसिक फर्क वो ये है कि यहाँ पर स्लिप रिंग्स की जगह स्प्लिट रिंग्स यूज हो रही है। स्प्लिट रिंग्स को हम क्या कहते हैं, कम्यूटेटर भी कहते हैं। तो यहाँ पर स्प्लिट रिंग्स यूज हो रही है स्टूडेंट्स, जिसे कि हम कम्यूटेटर भी कहते हैं, और इस चेंज के कारण, इस चेंज के कारण हमें एक्सटर्नल सर्किट के अंदर हमेशा करंट की डायरेक्शन सेम मिलती है। इसलिए जो करंट जनरेट होता है वो किस नेचर का होता है, वो डायरेक्ट करंट होता है, यानी कि डायरेक्ट नेचर का होता है, यानी कि डायरेक्शन चेंज नहीं होती है। हर हाफ रिवॉल्यूशन में हमें करंट की डायरेक्शन एक्सटर्नल सर्किट में सेम मिलती है। सो स्टूडेंट्स, लेट्स सी दैट in a split ring, P and Q are the two halves of the same ring. The ends of the armature coil are connected to these rings and these rings rotate with the armature. Now here students, we can see that the construction of a DC generator is almost same to that of an AC generator, except the fact that here we are having a single ring which is split into two halves. So here what we have is, we have split rings P and Q. Here you can see this is the P ring and this is the Q ring, and they are split. That is, we are having a single ring which is split into two halves. One half is known as the P part and the other half is known as the Q part. So here what we see is that the AB arm is attached to one half of the slip ring and the CD arm is attached to the other half of the slip ring. And what we see is that the two brushes X and Y, here we have named the brushes as X and Y and the split ring as P and Q. So X, the brush X is pressed against P and the brush Y is pressed against Q. And what we see is this brush X connects the split ring P to the external circuit and the brush Y connects the split ring Q to the external circuit where we have a galvanometer attached. Now what is the difference? Here what is the difference students? That in place of two slip rings we are using a single ring which is split into two equal halves. Now let us see students that how the working changes. Now here students, again for simplicity we have drawn a simpler diagram. What we see is that as there was in AC generator, we are having two magnets, two poles of the magnets, and here the north pole and here we have the south pole, and the armature coil ABCD is allowed to move through the axis in between these two strong poles. So what we see is that the direction of magnetic field is the same, and now since the armature is made to rotate again in the anti-clockwise direction, so this AD arm is moving inwards and the BC arm is moving outwards. So the direction of current in this arm is going to be downwards and in this arm it is going to be upwards, as we calculated by the Fleming's right hand rule. So what we see is that the current from this AD arm, it comes through this split ring P and through the brush B1 it goes in the external circuit, and in the external circuit we see that the current is in downward direction and the galvanometer shows right hand deflection. Then this current enters through the brush B2 to the split ring Q, and from here the current enters the armature coil and the direction of current in the BC arm is upwards. Now after the half rotation, what we see is that the AD arm is now shifted towards the right hand side and the BC arm is now towards the left hand side. Now students, after the half rotation, that is when the armature coil has rotated through 180 degrees. So what we see is that now the BC arm will move inwards and the AD arm will move outwards. In this arm BC, the direction of induced current is going to be downwards, as we calculated with right hand Fleming's rule. And here in the arm AD, which is moving outwards, the direction of current is going to be like this. So what we see students, that now since this arm BC is connected to the split ring P, then what happens is the direction of current is again the same in the external load, and the galvanometer is showing the direction, the deflection in the same direction. Here what we see is that the galvanometer is again showing deflection in the right hand side. So, what we see is that the current enters the split ring Q through the brush B2, and what we see is that in the external load the direction of current remains the same due to the change in the construction. Here we are having split rings P and Q in place of slip rings, right students. So, as is clear from figure A and B, by using the split ring, the direction of induced current does not change in the external circuit throughout the complete rotation of the armature. In other words, the current in the external circuit always flows in the same direction. Hence, the induced current is unidirectional, that is direct current DC. So, in this way students, mechanical energy is converted into electrical energy, and the electrical energy hence produced is direct current, as the direction is not changing with time. So, students, today we learnt about AC generator and DC generator. So, now we are ready to solve some in-text problems given at the end of this topic. So, let us solve the in-text exercises. Now, question number 1. State the principle of an electric generator. The electric generator works on the principle that when a straight conductor is moved in a magnetic field, then current is induced in the conductor, that is, electric generator is based on the principle of electromagnetic induction. So, we will write the principle of generator like this. Right students, now let us see the next question. Question number 2. Name some sources of direct current. Now we need to write the sources of direct current. So we will write the answer like this. Some sources of direct current are dry cells, button cells, lead accumulators. Right students, now let us see the next problem, which is question number 3. Which sources produced alternating current? So, we have to give the name of sources of alternating current. So, we will write the answer like this students. Alternating current is produced by AC generators of nuclear power plants, thermal power plants, hydroelectric power stations, etc. Now, let us see the next question. Choose the correct option. A rectangular coil of copper wires is rotated in a magnetic field. The direction of the induced current changes once in each. Option A, 2 revolutions. Option B, 1 revolution. Option C, half revolution. And option D, 1/4 revolution. अब बच्चों, आपको यहाँ पर बहुत अच्छे से पता है, अभी हमने किया कि एक AC जनरेटर के अंदर हाफ रिवॉल्यूशन के बाद में करंट की डायरेक्शन चेंज हो जाती है. तो यहाँ पे जो करेक्ट ऑप्शन है वो कौन सा है? वो ऑप्शन है C, हाफ revolution. So, after every half revolution, the direction of the induced current changes. So, students, today we have completed the topic AC generator and DC generator. So, for the next video, stay safe, stay healthy, bye.